The first lesson for unit, I've never used that before. The first lesson for unit 3 is the quadratic formula. And our essential questions are, how does the quadratic formula help me solve an equation? And what else can I learn from the quadratic formula? I'm going to move this over here. So first, we need to know what the quadratic formula is. So please write this down. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. The a, b, and c that we'll use in the equation comes from a standard form quadratic equation. So I use this with y equals ax squared plus bx plus c, which is a standard form quadratic equation. And I have a rule on that. I have a limitation that y has to be 0. So I have ax squared plus bx plus c equals 0. And then the a and the b and the c are the numbers that I'll substitute into the quadratic formula. So that I can solve for x. Oh. Okay. I would like to use this problem first. So you can pause it if you need to. Go ahead and write your problem down in your notebook. And this is what we will solve. So I've written the problem down here. It looked a little strange on my Post-it note on my computer. The t squared looked odd, but this will be the equation that we use to model the height and feet of an arrow shot into the air at time t in seconds. The question is, how long to the nearest tenth does it take for the arrow to hit the ground? So we have a problem here. The equation is written in function notation. And basically I have height in feet versus time in seconds. And I'll shoot an arrow. And I want to know this time. How long does it take for the arrow to hit the ground? So I'll use this equation. I told you that you would need to have a standard form equation, and we do here. It's just that it's written instead of y equals, it has h of t, height is a function of time, and instead of x, which is generic, we use t for time, which is what we're using for our x-axis. So when I compare these two equations, I would say that a must be negative 16. That's the number that's multiplied times the squared variable. And B must be 70. That's the number that's multiplied by the regular single variable. And the number that's a constant with no variable with it is 6. So that's C. And I'll substitute these into the quadratic equation. First, I set this up. You don't have to always do it this way, but I think probably it's a good idea for our first example to set it up like this. I do recommend that you always use parentheses when you substitute, but you don't have to go to this extreme of labeling everything and all that. All right, my equation is set up to substitute. So everywhere there's a B, I'll write 70. And everywhere there's an A, I'll write negative 16. And everywhere there's a C, which is just this one place, I'll write 6. What I recommend as for simplifying this is to not rewrite it and rewrite it. Well, we will rewrite it and rewrite it, but only 2 times. So I can simplify this and take some of the parentheses out and doing some consolidation. Negative times 70 is negative 70. Plus or minus is a combo package. It's because this, the time would be, or the height, sorry, the height y would be 0 when I shoot the arrow and when it hits the ground. So one of these times when the height is 0 will be if I have minus 70 plus this and divided, and one will be if I have minus 70 minus all of this and divided. But there's so much to write that we combine these and write it as plus or minus. And you need to know that that means, well, we say plus or minus, but really it's plus and minus. It's 2 different answers. Okay, so I have negative 70, add and subtract this, and then 2 times negative 16 is negative 32. So the first calculation we'll do is we'll put this whole, everything under the radical all together into the calculator. So I have a Desmos calculator open, and I will type, I need this to show what I'm typing. Here, put it over here. Oh, yes. And type it just like it shows here. This parentheses with the 70. And then minus 4 parentheses, negative 16. The calculator knows that means you're multiplying times 6. Use parentheses when you substitute, that way you won't have a sign error. And just type what you're substituting in. I put everything that goes under the radical into the calculator, and I get, oh, I didn't square this. Whoops. There. I get 5,284. So I'll transfer that to, this is simplified now under the radical. 5,284 is not a perfect square, but you can check that. $5,284 is 7, or square root of that is 72.691 whatever. Since it's not a perfect square, we won't continue to simplify right now. It'll be a decimal, and I will just write it as square root of 5,284 until I'm ready to do my calculation, which is now for all practical purposes. I'll go ahead and split up my X numbers, my times. You could write it as T because that's how the equation is written. Time and seconds will be -70 plus square root 5,284 divided by -32. And time will also be -70 minus square root 5,284 over -32. So I split up the adding and subtracting. Adding is one solution, subtracting is a second solution. That's how I get these two places where it crosses when height is 0. So I'll put this in the calculator. -70 plus square root 5,284. Now, be really careful about how you type this into the calculator because the calculator does not know what you mean. It only does exactly what you tell it. So I know that I need to divide all of this by -32. But if I just type divide -32, this is not the problem I'm trying to solve. So be aware of what you're typing in. I need to go out of this radical, but if I do the division from here, it looks like this, that's not right either. So that'll affect, of course, that affects your result, your calculation. So be careful about what you're typing in. If you are using a Desmos calculator and you did not start out with some fraction format, you can put a closed parentheses right here, and it puts a little shadow opening parentheses to acknowledge where it would have started. And from there you can divide, and it makes a fraction for you so that it looks like what you've written over here. Okay, my solution is -0.08 4 time 0. This is the time when I shot the arrow. This is not helpful to answer my question. How long does it take for the arrow to hit the ground? I don't want to know 0 seconds, -0.08. This is an extra solution. It solves the equation, but it doesn't help answer the question that I'm asking. It is correct for this equation, but since it doesn't answer the question I'm asking, it's extra or extraneous. On your practice problems, I asked you to give the extraneous solution and a reasonable solution. So I'm hoping that this other calculation will give us a reasonable answer. If I just change this addition to a subtraction, I get 4.459 It says here in the problem description to round to the nearest tenth. So I'll write this as 4.5 seconds. When you have word problems, you should have units with your answers. And this is how you can use the quadratic equation to solve a problem. With many of the problems that I gave you with your practice, there are follow-up problems. An example of a follow-up problem that would go along with this is how high does the arrow go? What's this maximum height? Well, this is a symmetrical graph. So if I cut it in half, I'm cutting my time in half also. So to find what the height is, I need to know how long it takes to travel to there. If my time to hit the ground is 4.5 seconds, which is what I just calculated, then the time to get to the top, the highest point, would be half of that. Four and a half divided by 2 is 2.25 seconds. So to answer a follow-up question, how high does the arrow fly? I would write my equation down and I would substitute for time, the time at the maximum point, 2.25. So the same equation, -16 time squared plus 70 times time plus 6. And everywhere I use the t in my equation, I put 2.25 seconds. And using this substitution, get my calculator back out. I have -16 parentheses 2.25 squared plus 70 parentheses 2.25 plus 6. 82.5. My height is in feet. So my maximum height halfway through the path in time is 82.5 feet. Please do your word problems for practice 3-1 and then look back and watch the other video.